Hi, Selena. This is Miss Winslow. I know that we have not had a chance yet to actually meet in live classes, but I do want to thank you for reaching out. I understand that you wanted some help with our 1.02 expressions lesson in OMHS, so I went ahead and put this PowerPoint together, and hopefully this will help. So this is the first one we're going to look at. I know that you were saying that you were having a little bit more trouble with the fractions, but I thought we would just start at the beginning. So when we're simplifying expressions, an expression is basically anything that does not have a variable. So you see we don't have any x's in here, no y's, they're just numbers. So that's what we call an expression. And we're going to use what we call PEMDAS. I'm not sure if you remember PEMDAS from last year. And PEMDAS helps us with order of operations. So remember, P stands for parentheses, and E stands for exponents. M stands for multiplication. D stands for division. Oops. A stands for addition. And S stands for subtraction. Okay, before we go much further, I just want to remind you that since this is a recording, you can pause the recording at any time. So make sure that you do have some paper with you, a pencil or a pen, so you can take some notes down as you're watching. And if at any time you feel like I'm talking too fast, since you're not here with me, you can just press pause and kind of catch up. All right, so for this example, we are going to start with parentheses. So 3 minus 1 here is 2. And I'm just going to bring everything down. I also want a quick reminder that you are allowed to use your calculator in this whole class, although I do believe there is definitely value in understanding how to do a problem without the calculator. So we're going to kind of use both, right? Our brains and our calculator, and both at the same time. You definitely need a brain to use a calculator. All right, so we've done parentheses. I don't see any exponents in this problem. Remember, exponents are those little tiny numbers that you would see next to a large number. So here's an example, 2 squared. This little tiny 2 is the exponent. So there are no exponents in this problem. We do have some more parentheses, right? And it is considered multiplication. So when you have two numbers right next to each other like this, that's considered multiplication. So we're going to do negative 4 times 2, that's negative 8. And now we can just go ahead and add these two numbers. Negative 8 plus 2 is negative 6. And that is our final answer. All right, let's go to the next example. It says, what is the value of this expression? So again, we're going to remember PEMDAS. You may have heard teachers in the past use GEMDAS. The G standing for grouping symbols. So sometimes we like to replace the parentheses with grouping symbols because you can see in this example, we have multiple sets of grouping symbols or parentheses, right? We have the parentheses here by the 1 plus 5, and then we also have the brackets around that entire set of expression there. So you can have multiple grouping symbols, and you just want to basically work your way from the inside out. So we're going to start with this grouping symbol first. 1 plus 5, so that's 6. And then I'm just going to bring everything down. Let me bring those parentheses down, might help us keep everything straight. All right, now working from left to right, just like you read a book, we're going to say, okay, what do we have next? Well, we do have more parentheses here. We don't have any exponents, and here's that multiplication. Again, a lot of times a parentheses right next to a number like this, it also means multiplication. You can write multiplication so many different ways. You can write it just like this with parentheses. You can write it using a dot. You can write it using an asterisk. You can also write it using an X. Isn't that funny? The higher up we get in math, the more options there are. So all of these mean the same thing. So over here, we're going to do 6 times 2 is 12. And then I'm just going to bring everything down. All right, now working with this grouping symbol here, we have 12 minus 5. And that is 7. We'll bring down the times 2, and you get 14. Again, you're very welcome to just double check your math with your calculator. I do feel like the last two examples, we probably don't need a calculator, right? But it doesn't hurt. I mean, everybody makes mistakes. I make mistakes. It happens for sure. So you could always just double check yourself. Okay, 6 times 2, yes, that's 12. 12 minus 5, yep, that is 7. 7 times 2, yes, that is 14. So you're definitely welcome to double check any work with your calculator. All right, so before we get to the next examples, I thought we could do a review with fractions. So remember, to add fractions, they have to have the same denominator. So here's an example, 1/2 plus 1/2. The number down here on the bottom, that's the denominator. Denominator. And the number on the top is called the numerator. So in order to add fractions, they have to have the same denominator. And these do. It makes them basically like terms, you know, like adding apples and apples, oranges and oranges. These are halves and halves. So when that happens, you can you can add the numerators straight across. So 1 plus 1 is 2. And then you keep the denominator, whatever it is. So 1/2 plus 1/2 is 2 halves. See, 2 halves. And of course, we know we can write 2 over 2 as just 1. So a half plus a half is a whole. Let's try another example. If we had like 2/3 plus 4/3. So the denominators are the same. They're both 3's, so we can go ahead and add them. 2 plus 4 is 6, and then we keep the denominator. 6/3. Now you can leave it like this, or we can definitely reduce it to 2, right? 6 divided by 3 is 2. So what if the denominators do not match? So maybe something like 1/2 plus 2/3. So you can see these denominators do not match. And what we have to do, besides using a calculator, is we have to make them match. So we have to find something called a common denominator. And the easiest way, I think, to do that is to multiply both of the denominators by the other one. So we're going to multiply 2 times 3, that's what's over here, and we're going to multiply 3 times 2, because that's what's over there. So see what we did? We made them both 6, right? 3 times 2 is 6, and 3 times 2 is 6. So that makes them common. That makes them the same. But the thing about math is you can't just like throw numbers in there anywhere, right? If we did 3 on the bottom here, we have to multiply by 3 on the top. You have to keep it equal. Because look, 3 over 3, that's just 1. So we're really not changing the value of the fraction. We're just changing the way it looks. And then over here, we'll multiply the top by 2 because we did it on the bottom. So this new numerator is 3 times 1. And the new numerator over here is 2 times 2. So if you don't believe me, you can grab your calculator. 1/2 is the same exact thing as 3/6. You'll get the same decimal. It's 0.5. So we didn't change the value. All we did was we changed the way it looks. So that way we're able to add these fractions now easily. With both 6 in the denominator, so we can just add the numerators, and we get 7 over 6. That's that answer. So now I would love for you to pause this recording and try this one on your own. And then click play and come back for the answer. So we're going to do 2/7 plus 1/2. All right, go ahead and press pause. Try to find that common denominator and add them together. Okay, so again, the easiest way is to just multiply each side by the other number. Oh, I have a rainbow pen going on here. I don't know how that happened. But remember, you want to keep them the same. So if I multiply by 2 on the bottom here, I multiply by 2 on the top. And the same over here. So now these new fractions are going to be 2 times 2 is 4, over 14 is our common denominator, and 1 times 7 is 7. Now that the denominators are the same, you can add the numerators. 7 plus 14, 7 plus 4 is 11 over 14. I'm not going to use this pen anymore. That's funky. Sorry about that. So you get 11 over 14. There we go. All right, here's the thing about subtracting that's really cool. It's just like adding, except you're subtracting. So let me grab a different pen. There we go. Again, if the denominators are the same, you can just subtract the numerators. 1 minus 3 is negative 2. Of course, you can write that as negative 1, right? Because 2 divided by 2 is 1. Now again, if they're different, we have to find that common denominator. Now it's hard to make up numbers. There we go. Okay, so we're going to just multiply this one by whatever is over here. So that's 4 on top and bottom, and then 3 on top and bottom. So we get 8 over 12 minus 9 over 12. And now that we found that common denominator, we can go ahead and subtract the numerators. 8 minus 9, negative 1 over 12. That's the answer. And again, you can always use your calculator to check your work. All right, now I would like for you to try this one. Go ahead and pause the recording and you can try this one on your own. Just click play when you're done. So multiply this side by 4 and this side by 5. So we end up with 8 over 20 minus that 35 over 20. So we get 27 over 20. That's a big fraction. All right, so addition and subtraction function the same way. You find that common denominator, and then once you have it, you can just go ahead and add or subtract the numerator, the number on the top. So now when we're talking about multiplication, multiplication is pretty cool because all you do is multiply straight across. In multiplication, the denominator will change. So we have 1 times 3 is 3, and 2 times 4 is 8. So you just multiply straight across. The denominators do not have to be the same. You're just multiplying straight across. So why don't you pause it and try this one? And then press play. And check your work. All right, so we got 8, 2 times 4 is 8, and 3 times 7 is 21. So the other thing you might see, excuse me, is, and I didn't make this its own slide, but it's essentially multiplying. So you might see something to a power. So like 1/2 squared, we have this little 2 up here. And that little 2 means you're going to write this number twice. So if you see a 2, it means, oh, I'm going to write 1/2 times 1/2. Grab my tablet here. Okay, here's another example. If you had 2/3 cubed to the third power, it means you write it 3 times. 2/3 times 2/3 times 2/3. That's all that means. And then look, you just have a multiplication problem like we just did. You would do 1 times 1 and 2 times 2. Here you would do 2 times 2 times 2 and 3 times 3 times 3. So the power or the exponent, it just lets you know how many times to write that fraction or even that number. It doesn't have to be a fraction. It could be, 2 to the 4th. That means you're going to write the 2 4 times and multiply. That's all that means. Okay, so let's try one. So this expression says to simplify. So again, we're going to use PEMDAS. We're going to go for parentheses first. So there is a set of parentheses here. It's around just a single number, that fraction. We could definitely take care of this now if you wanted to. I mean, it's a legal move. It's a legal move, not an illegal move. It's allowed. So we can do that first. Some people might start here with this set of parentheses just because that's what PEMDAS says. But I'm going to go ahead and start here because we're allowed to. So 1/2 squared means to write 1/2 twice. And then I'll bring everything down. So then we're going to do 1 times 1 is 1. Oops. And 2 times 2 is 4. There we go. We did 1/2 squared, or 1/2 to the second power. We wrote it twice. Now let's go ahead and do the set of parentheses. This is 2 minus 1/2. Now we have a whole number minus a fraction. Oh, I wrote that wrong. Do you see that? Look at that mistake I just made. I'm so glad I caught it. It's 2/3 here and it's 1/2 there. Why would I have written 1/2? That's silly. All right, let me fix that. Hopefully you were screaming at your screen, going, Miss Winslow, you wrote it wrong. I hope that's what you do in regular class, if it ever happens. Okay, 2/3. There we go. So we have a whole number minus a fraction. So the denominators are not the same. We didn't talk about this yet, but what is the denominator on a whole number? There's nothing written. So when there's nothing written, it's a 1. So you can turn any whole number you want to into a fraction. You just put a 1 underneath of it. Okay, now look, we can do this. We just reviewed this. This is subtracting fractions. So we're going to make that denominator match. So I'm going to multiply this one by whatever the other one is. That's a 3, top and bottom. I'm going to multiply this one by whatever the other one was. It's a 1, top and bottom. So we really have 6/3 minus 2/3. Now that the denominators match, we can go ahead and subtract the numerators. So if it's okay, I'm going to come up here. I kind of write big, sorry. 1/4 minus 6 times. Okay, 6 minus 2 is 4/3. Okay, so we did parentheses, we did exponents. Now we're going to do multiplication. So here's that little number next to that parentheses. Remember, that means multiply. So we have 6 times 4/3. Now, some people can just go ahead and do this. I like to make them look like the same kind of numbers. So similarly to what happened over here, remember a whole number minus a fraction, we have a whole number times a fraction. So let's make it look like a fraction. Remember, you can put any number over 1. So now remember, with multiplication, you just get to multiply straight across. So 6 times 4, 24. And 1 times 3 is 3. This is a doozy of a problem, isn't it? It's got lots of steps. I mean, I like those, but I can see my paper getting full. All right, we're almost done. Now we have another subtraction problem, 2 fractions. And remember, with addition and subtraction, we have to make the denominators match. So I'm going to multiply this one by whatever the other fraction is, 3. And this one by whatever the other one is, 4. So over here, we're going to have 3/12, right? 3 times 1 is 3. 3 times 4 is 12. Minus, wow, 24 times 4, that's a big number. I might even just grab my calculator to confirm. Let's see. I know 4 times 4 is 16. 4 times 2 is it 96? I hope it's 96. I'm just going to confirm. Well, 25 times 4 is 100. Yeah, it's 96. Okay. I don't want to guide you astray when you're not even in the room with me. All right, so now that the denominators match, we can go ahead and subtract the numerators. 3 minus 96 is negative 93. These numbers look strange to me. Does that number look strange to you? Honest, I just took my calculator to confirm all of this because I thought there's no way that the answer is negative 93 over 12. That's so bizarre. But it is. The only thing we haven't done yet is we need to reduce this fraction. So in math, we like to have the answer as low as it can possibly go. So we want to think, well, how can negative 93 over 12 be reduced? Is there any number that goes into both of those evenly? And sometimes it's helpful to kind of try by twos. You know, like does 2 go into 12? Does 2 go into 93? And it does. But not evenly, excuse me. So what I would recommend at this point, we're definitely going to get into a whole lesson on reducing fractions, but I'm going to guide us to our calculator. And when you type negative 93 over 12, excuse me, you get negative 31 over 4. So it reduces to negative 31 over 4. So that must mean 3 goes into both of these. So 3 goes into 12 4 times, and 3 goes into 93 31 times. All right, so I'm not going to put one up here for you to try. Let me go back for a second. So I'm going to make this up, so hopefully the numbers don't get too weird. Let's just try this. All right, so go ahead and pause the recording, try it on your own, and then come back for the answer. Okay, so we have the little squared here. Remember, that means to write the number twice. 1/3 times 1/3. So with multiplication, we just go straight across. 1 times 1 and 3 times 3. Ooh, the same thing's going to happen here. Look, I put the 2 over 1 to make it look like a fraction. And then we're just going to multiply straight across. 2 times 2 is 4. 1 times 7 is 7. All right, now we're doing subtraction, right? So remember, with addition and subtraction, we need the denominators to match. So I'm going to multiply this side by whatever's on the other one, the 7, and similarly this by the 9. So we're going to have 7 over 63 minus 36 over 63. So we do 7 minus 36 and get negative 29 over 63. Now I'm just going to confirm that that doesn't reduce further. You can do the same thing on your calculator. And it does not. So these are prime numbers. So there are no numbers, well, there's not one number that goes into both of them evenly. So we are reduced as low as it can go. All right, let's try this one. So remember PEMDAS. We'll do parentheses first. So that means what's inside the parentheses. So we're not going to touch this little 2 until we've done what's inside. So we're going to subtract those fractions. Now this is nice. The denominators are already the same. So all we have to do is subtract those numerators. 3 minus 1 is 2 over 8. Okay, now we can do exponents. So it's up to you. If you want to, you can reduce this 2/8. Some people like to reduce first, and some people like to reduce at the end. It's kind of up to you. If we reduce now, the numbers get smaller. I guess I'll show you both ways. So let's keep it 2/8. You'll get the same answer either way. Or we could have done this. 2/8 reduces to 1/4 because 2 goes into 2 one time and 2 goes into 8 4 times. I hope this is not confusing you, this part. I just kind of wanted to show you both ways. You can reduce this fraction first, like we did here, or you can just go ahead and write it down and we'll reduce it at the end. All right, so now multiplication, we're just going to multiply straight across. So 2 times 2 is 4. 8 times 8 is 64. So see, these numbers got kind of big because we did not reduce here. Now let's find our common denominator. 2 times 64, 64 times 2. These are going to be honking numbers. 64 over, okay, I'm just going to check on the calculator. 64 times 2 is 128. Right? So then we're just going to go ahead now and add 64 plus 8 on the top and get 72 over 128. I'll just make sure that doesn't reduce, and it does. It reduces to 9 over 16. So let's see what happens if we were to do it this way, if we were to reduce first. So we're here and we have 1/2 plus 1 times 1 is 1. 4 times 4 is 16. So to find our common denominator, we'll multiply this side by 16 and this side by 2. So you get 16 over 32 and 2 over 32. Is that right? Yep. Okay, now we're going to add our numerators, 18 over 32. Now we'll just, these numbers are much smaller, right, than that 72 and 128. So it might let you more easily see how we can reduce the fraction. And this one also reduces to 9 over 16. Because both of them are divisible by 2. 2 goes into 18 9 times, and 2 goes into 32 16 times. All right, now let's have you try one. 1/3 cubed plus 2/3 minus 4/3 squared. Okay, this is where you press pause and you try it on your own paper. So the cubed makes us write 1/3 3 times. We're going to go ahead and subtract the fractions because the denominators match. We can subtract the top numbers, the numerators. So you get -2 over 3 squared. All right, let's go ahead and multiply these 3 fractions straight across. 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 3 is 27. So be careful there. We don't want to accidentally add them, right? Or we don't want to accidentally count by threes, 3, 6, 9. That's basically adding them. Remember, we're multiplying. So 3 times 3 first, that's 9. And then 9 times this 3 is 27. All right, this 2 here, the little 2, makes us write the fraction twice. And now we can multiply. So a -2 times a -2 is a +4. +3 times a +3 is a +9. Okay, I'm going to show you something different here. It's not really a trick, it's just like a shortcut. So you know, in the last few examples, I had said to find a common denominator, we can just multiply this fraction by whatever's over here and vice versa. And that will absolutely work every single time. That's why I kind of like it. You don't have to really think too much. You can just choose whatever number it is you would multiply it by. So this would be 27 times 9 and 9 times 27. But sometimes the numbers get kind of big, right? Like we would have 27 times 9. That's pretty big. So another thing you can do, if you recognize it, so you can see here that 27 and 9 are multiples of each other, right? Like if you were to count by nines, 9, 18, 27, ooh, we would hit 27. So when that happens, to make these common, all we have to do is we could just fix one of them. As long as you're doing the same thing to the top and bottom, you don't have to do it to both fractions. The goal is to make the fractions common And we did that here. 9 times 3 is 27. So now see, they're both 27. This does not always work. It only works if the numbers are multiples of each other. And again, I hope I did not confuse you. You can absolutely use the same method we used the whole time. You can multiply this 27 by 9 and this 9 by 27. You'll absolutely get the same exact answer. Just wanted to show you a different method. Okay, so now that these denominators match, we can go ahead and add the numerators. So 1 plus 12 is 13, and then we bring over the 27. All right, here's our last one to simplify. Again, we're going to keep PEMDAS in mind, or GEMDAS if you like that better. So I don't see any parentheses or brackets. So let's go to exponents next. Here's this little exponent. Don't forget, even with this one, you can go ahead and press pause and try it and then come back for the answer. So let's bring everything down. 4 squared just means 4 times 4, right? 4 times 4 is 16. All right, now we're going to do multiplication. Well, there is no multiplication really. I mean, we did it right here, right? And division. 16 divided by 16 is 1. I brought down the minus. Remember, a minus and a negative are exactly the same thing. So you could have said negative 16 divided by 16 is negative 1. And now we subtract. 4 minus 1 is 3. Oops. That one was a little prettier, right? Because there were no fractions. All right, you got this. I just want to say that I'm super proud of you for having the maturity to reach out to me. I love that you called me. In the future, I think just like the quickest way will be to email me with the exact lesson. And even if you can, like this question or like a screenshot of the question, you don't really have to, but if you can, it's super helpful. But as long as you tell me what lesson and maybe even what types of questions you need help with, then we can definitely go from there. I was telling your mom that sometimes I might call you back when you're free to talk through it. Sometimes I might just email you back with an explanation written out. Sometimes I might send you a video like this. And sometimes I might invite you to a one-on-one session where we can work together live in a class, but just ourselves. Starting next week, we are going to be in live classes together, and we're also going to have access to office hours. And then I have a co-teacher who is going to be holding some extra sessions as well. So there's definitely going to be a lot of opportunities for you to get help when you need it. So I really hope that this was helpful. Please reach out if you need any more help or have any more questions. The last thing I'll say is as you're going through your lessons on your OMHS, online, middle, and high school, don't forget to go through the entire lesson. So you want to make sure you're watching all the videos. Hopefully you can. I know there's been some tech issues, but in general, you want to watch all the videos, try all the practice, check all the work, and then do the review, because there's always a review, and then try the quiz. If for some reason you don't do well on the first attempt of the quiz, then remember you get 3 attempts. Then I would say to go back and do it again. Maybe you missed part of the lesson, maybe you accidentally clicked through too fast on one part. And then before you take your second attempt, check with your mom, your learning coach, check with me, just to make sure that you're ready to go. Okay, I hope you have a great day, and I'll see you next week in classes. Bye.